Hey Naomi, I got your questions about questions 1, 2, 3, 6, 7, 15, 16, and the formula for number 28. All right, so this is some explanations for them. Number 1 says the point 3, -4 is on the terminal side of an angle theta in standard position. Which sine of theta? So I would draw the coordinate 3, -4. So it means you start at the center, go over 3, go down 4, plot the point, and then draw the right triangle. And I know that it goes down 3, it goes to the right. I'm going to down 4, it goes to the right 3. I know this is 3, 4, 5 right triangle, so I know that length is 5 if I use Pythagorean theorem. It says find sine of the angle theta. This is the reference angle. This would be theta. So sine of that angle would be opposite side over the hypotenuse. So it should be -4 over 5. And that would be answer choice C. All right, and not sure why I'm marking my original key, but if we're working out right now, it should be answer choice C. Number 2, it says which quadrant is 210 degrees in? If you think about that, if this is 180 degrees, and this is 270 degrees, 210 should be somewhere down here in that quadrant. So that's quadrant 3. Number 3, it says which of the following is coterminal to theta equal to 200 degrees. Coterminals, you add or subtract 360 from it. So I could add 360 to 200. Now I get 560. And 560 is not an answer choice. So I could subtract 360 from 200. And then I could find that the output is -160. -160 is an answer choice. So answer choice B. Number 6 was the next one you asked about. It says that find theta if cosine of theta equals to -1/2. So one way you could do this is write the equation cosine of theta is -1/2. And you could just say theta equals the cosine inverse of -1/2. And that should work. I'm going to check it out by plugging my calculator. Let's see what my calculator says. My calculator says it's 120 degrees. That may be the most direct way. The only other way you could do it is use the unit circle, but you don't have to. It's just -120. On the unit circle, because accordingly go cosine of theta and then sine of theta. You look all across the unit circle and you look for the coordinate where the cosine value is -1/2. And if it's 120, it must be over here. So it must have been the cosine is -1/2, and when it been sine, it's probably going to be the square root of 3 over 2. So that would be the coordinate where cosine is -1/2. Either way would work. Either use the unit circle or use your calculator to find the inverse. Next we asked about was number 7. Number 7, same type problem as the last one. They gave you a coordinate 40, 9, 40, -40, 9, and then they said to find out the cosine value at that place. So apparently you went left 40, up 9, and then I need the hypotenuse. So the hypotenuse is going to be a squared plus b squared equals c squared, which is 9 squared, that's a 9, and -40 squared equals a c squared. So it's going to be the square root of whatever 9 squared plus, well, I'm going to go call it +40 because when you square it's going to be positive anyway. So c is going to be the square root of whatever 9 squared plus 40 squared is. Looking at the answer choices, I want to bet it's 41. And if that's true, cosine is going to be adjacent over hypotenuse. So I'm getting -40 over 41. Answer choice A. Next we ask about number 15. Number 15 says, evaluate arc cosine of that angle. Arc cosine means sine inverse. Arc cosine, not sine inverse, means cosine inverse. So arc cosine, same thing as saying cosine inverse of negative square root 2 over 2. I just know for the unit circle, that's a 45-degree reference angle, as where cosine is negative, which is right here. So I know that's 135 degrees. But you can plug that into your calculator too. You plug that directly into your calculator, cosine inverse of negative square root 2 over 2, you should get 135 degrees. I knew it was a 45-degree reference angle because that square root 2 over 2 in the unit circle tells you it's a 45, 45, 90 right triangle. So all those are those coordinates that are either 45 or that 135 or 225 or 315. All right, leaving that alone. The next we asked about was 28, the formula I need for 28. All right, so 28 says, oh, they gave you the formula. That's the law of cosines formula. And they actually find A, B, and C, and D using law of cosines formula. So they gave you the side links. They did not give you the uppercase letters. So I was working on that. It looks like A is 5, or C is 10. So I could say 10 squared equals to 5 squared plus 7 squared. Subtract 2 times 5 times 7 times the cosine of angle C, which we do not know. So this is going to be 100 equals 25 plus 49, subtract negative 10 times 70, so it's, it's negative 70, cosine of angle C. And if you continue working on that, long story short, you can subtract 25, you can subtract 49, you can divide by negative 70. So you ultimately going to get cosine of C equals to 100, subtract 25, subtract 49, divided by negative 70. And you do the cosine inverse of that. So I'm going to change the color. So C is going to equal to the cosine inverse of that entire thing right here. 100, subtract 25. Try to make it not bounce around so much. So try that again. 100, subtract 25, subtract 49, all over negative 70. And when you do the math for it, you're going to get angle C. Now, after you do that, you can find angle A and angle B the exact same way. They got different formulas, though, for angle A and B. So in order to do that, you have to use, so for lowercase a, it's going to equal to B squared plus C squared, subtract 2AC, times the cosine of angle A. And then B is going to be the same thing. It's going to be B squared equals to A squared plus C squared, subtract these two letters. So AC, cosine. If this is B, this is going to be capital B. You can do the same thing for each one of those, and you're going to find the angle for each one of those. After you get two of the angles, so you can find a third one by subtracting from 180. I hope you understood that. Hope that works. Hope that helps. Good luck.